Hi everyone, this is RK and you are watching VV Academy channel. Today we are going to discuss about Kirchhoff law, and using this law we are deducing the condition for balancing in a Wheatstone Bridge. So first of all we will go through what is the Kirchhoff law and what are the laws come under this one. So under Kirchhoff law we will get two laws, that is junction rule and another one is loop rule. And here junction rule tells us that at any junction the sum of the currents towards the junction is equal to sum of the currents away from the junction, or you can write as algebraic sum of the currents around a junction is 0. So this is called as junction law. For example, some of the inward currents, incoming currents are I1 plus I2, and some of the outgoing currents are I3 plus I4 plus I5. So this law tells this. Okay, so junction. So at any junction, the sum of the currents towards the junction is equal to the sum of the currents away from the junction. Okay. So now we will go through the next rule, which is called as loop rule. Algebraic sum of changes in a potential. So remember once again, algebraic sum of the changes in a potential around any closed loop. So if you consider any closed loop, there the algebraic sum of the potentials involving resistance also and the cells in the loop is 0. So these two laws come under Kirchhoff laws, and one is called as junction law, another one is called as loop rule. Okay, so using these two, now we will deduce the condition for the balancing of Wheatstone Bridge. So already we had given we had drawn the diagram for the Wheatstone Bridge. So that is the circuit which is given there, and so here, wait a minute, we will drop the board and then we will go through the remaining topic. So coming to the circuit here, so here we have taken the circuit. So this is the battery or the cell with the EMF E, and the current direction is like this, and there are 4 resistances connected in the circuit. One is a P, Q, R and S. So then now the current is flowing through the points A and to the point B. Now let us think the current flowing through A to C is I1, and A to D is I2, and C to B is I3, and here D to B is I4, and this is called as galvanometer, and the current across the galvanometer is Ig. So now applying this Kirchhoff law upon the 4 resistances P, Q, R and S. So I want to apply the first law at the junction C, means here. So at junction C, as we apply Kirchhoff first law, that is sum of the inward current is equal to sum of the outward current. So we get I1 is equal to Ig plus I3. So at C, this is the inward current and outward current will be these two, Ig and I3. So assume this as equation 1. Now coming to the next one at the junction D, means here. So as we are applying the Kirchhoff's first rule, I2 plus Ig will be equal to I4. Assume this as equation 2. So I told you I2 plus Ig will be equal to I4, because these two are coming in the same direction and this is the other direction. So inward and outward. So these are the two equations. Now applying Kirchhoff's second rule for the loop ACDA. Okay, ACDA. ACDA means this part. So when you apply that second rule, we will get minus I1P minus IgG plus I2R is equal to 0. Means the algebraic sum of the potentials including the resistance and the cells is equal to 0. According to that rule, we have written this one. Now from the loop C, B, DC, we will get minus I3Q. When I am writing this, if you had gone through the circuit, then you will get a clear idea. Plus I4 S plus IgG is equal to 0. This will be equation 4. Okay, so these two equations we got by applying second rule of Kirchhoff law, and these two equations we got when we applied Kirchhoff's first rule. This is about the junction rule and this is about loop rule. So let us think no current is passing through the galvanometer, then the bridge is said to be balanced. Then what will happen? So as we told that condition, so Ig is equal to 0. So as I told that no current is passing through the galvanometer, okay, then the bridge is said to be balanced. So Ig is equal to 0. Now let us substitute Ig is equal to 0 in these 4 equations. Equation 1, equation 2, equation 3 and equation 4. Then here in equation 1 we will get I1 is equal to I3. Then from equation 2, I2 is equal to I4. And in the same way, in equation 3, we will get I1P is equal to I2R. In the same way, I3Q is equal, from this equation, I3Q is equal to I4ES. So, by adjusting all this, you will get that P by Q is equal to R by ES. So this is the balancing condition for Wheatstone Bridge. Nothing but here adjusting means I simplified, nothing but I had taken this one. I1P is equal to I2P. So you can change the, you can keep, substitute the value of I1 which is given here, or I2's value here, okay, such that you will get this value. So this is nothing but a condition for the Wheatstone Bridge using Kirchhoff law. Now by using Kirchhoff law, now we will do the problems related to Kirchhoff law, which is very useful for the board examinations as well as for NEET and JEE examinations. So look into the sum which is given. So according to the given problem, they asked what is the current flowing in the given circuit. So in the circuit we had seen two resistors are there. One is 10 ohms, another is 20 ohms, and two potentials are given, 5 volts and 2 volts. And now we have to find the current flowing in the circuit. So I will apply loop rule in Kirchhoff. So according to that rule, the potential, sum of the potentials in the circuit will be equal to 0, including the resistance and the cells. So from here, as the current direction is like this, so we will start from here. So here the potential, the resistance is 10 ohms and current. So as we have to find the current, we will assume the current as I. So there it will be minus 10I. Okay. So now coming to this one, here directly potential we are having, that is 5 volts. And again now coming to here, minus 20 and current is I. Next coming to here, the potential is 2 volts. So according to the rule, which is equal to 0. So the now confusion is how we got, sometimes we are taking 10I and sometimes we are taking 5. So here phi is the potential V. Directly they had given the V value, and here also V. Here, according to Ohm's law, we know V is equal to IR. So in this way, we are taking this value. Okay. So we are taking the potentials. So according to the loop rule, we have written this one. So now minus 10i and minus 20i, it will become minus 30i, and plus here it is minus. So 5 minus 2, that will be 3. So that is equal to minus 30i is equal to minus 3. Then I is equal to 3 by 30, that is equal to 1 by 10, that is equal to 0.1 ampere. So this is the easiest sum, nothing but so this is the starting problem, such that we will go stepwise the level of the sum. So this is the easiest level, next sum will be a little bit, and third sum will be the hardest level. Okay, so note down this one, we will go through the next problem. This is the next problem. The level will be a little bit high with compared to the first numerical which we did. So here you can see a circuit given there. There's the current flowing through A and current is releasing from EF. Now they asked us question, what is the current flowing from A to D? Okay, so we had taken the currents. We assume that from this one, D to C it is I, and A to B is I minus I1, and in the same way B to E is I minus I1 minus I2, and E to F is I minus I1 minus I2, and from C to F is I minus I2. And one more thing they had given, that is each resistance is equal to 10 ohms. So here also we will use Kirchhoff's second rule, that is loop rule. So first one, here there are two mesh given. Let us think this is one mesh and this is another mesh. So we are applying the Kirchhoff rule in the first mesh, that is mesh A, B, C, D, E. This part A, B, C, D, E. So then according to loop rule, minus 10 I plus okay, we'll write like this, minus 10 I plus I1 means this part, and minus 10 I minus I1 and minus 10 I2 plus 20 I1 is equal to 0. So in this part we have taken this one. Each resistance is equal to 10 ohms. So here it will be minus 10I plus 10I1 minus 10I2 plus 20I1 is equal to 0. So here I1. So 10I1 plus 20I1, 30I1. Here minus 10I2 minus 10I. So if you have taken 10 as common, then we will get 3I1 minus I2 minus I. If you take minus I that side, it will be plus I. Okay. So this will be equation. Now we have to take another mesh, that is B, E, F, C, B. So in this we will get minus 20 I minus I1 minus I2 plus 10 I1 plus I2 plus 10 I2 is equal to 0. So on solving this, nothing but multiply 20 with this part and 10 with this and 10. Otherwise you can take 10 as common and it will be equal to 0. So we will get 3I1 plus 4i2 is equal to 2i. This is equation 2. So now solving equation 1 and equation 2. So here 3i1 plus 4i2 is equal to 2i, and equation 1 3i1 minus i2 is equal to I. Subtract this equation from this one, and here it will be 5i2 is equal to I. Okay, then I2 is equal to I by 5. So we got I2. Here nothing but it will be we have to find this one. So it will be I. Now what I will do is I will substitute this I2 value in equation 1. So then it will be 3i1 minus, instead of I2, I1 by 5 is equal to I. If we had taken this part to that side, then I plus I by 5, then 3i1 is equal to 6i by 5, 2 times. Then we got I1 is equal to 2i by 5. I1 is nothing but this part. So AD is equal to 2i by 5. So this is the part. So this sum we did with the help of a loop law. So this is nothing but it is also easiest part, but we have to understand what we have to do. So what I had did is, first I had taken the circuit and I divided into two meshes, that is A, B, C, D, A, and next one is B, E, F, C, B. Okay, so in that way we had taken two parts, and at last we solved these two equations. Then we got I2 value. With the help of I2 value, we substituted the I2 value in equation 1. If you want to substitute in equation 2 also, no issues. Then we got IAD. So current from A to D is 2I by 5. So note down this. We will go through the next problem. So this is a third numerical. So look at the given circuit given. So here current is flowing from the circuit from point A and point B, and at point A the current is 1 ampere, and here current flows like I1, I2, and in the circuit they are given 4 resistance, that is 60 ohms, 15 ohms and 5 ohms and 10 ohms, and they asked us to find the I value there. So at this point the current flowing is I plus I1 plus I2, which is equal to 1 ampere. So at junction A, I plus I1 plus I2 is equal to 1. This is equation 1. Okay. So now in this circuit we can make this as two loops. This is loop 1 and this is loop 2, and here I have drawn a line. Nothing but if you solve this part, you will get 20 by 3 ohms. Nothing but for the shortcut purpose we will do afterwards. So now we will consider each loop and we will apply loop rule to that, and now we will take loop 1. So apply only this part. Only this part we are applying loop rule. So according to that, 60i plus 15 plus 5 I1 is equal to 0. If you solve this, you will get I1 is equal to 3i. This will be equation 2. Now I will consider the second loop, this part, the bottom one. I have mentioned here loop 2. So then we will get minus 15 plus 5 I1 plus 10 I2 is equal to 0 according to the loop rule. On solving this, we will get I2 is equal to 3I1. Okay. So I1 value already we got in equation 2. Let us substitute here. Sorry. We will get 2I1. So 2 I1 value is 3I1. that is equal to 6R. This will be equation 3. Now solving equation 1, 2 and 3. Equation 1, 2 and 3, we will get I is equal to 0.1 ampere. So for the board examinations, this answer will be perfect. When we are coming to competitive examination, there is a shortcut, that is branch current is equal to main current into resistance of opposite branch by total resistance. So main current is 1 ampere into resistance of opposite branch, means this part. If you consider this one, this will be the opposite branch. The total will be 20 by 3, means these two are in resistance. So 15 plus 5, 20. 1 by 20 plus 1 by 10, then it will be 20 by 3 ohms. So that will be 20 by 3 by total resistance. 20 by 3 plus here it is 60. So if you solve this, then also you will get 0.1 ampere. Okay, so in this way also you can complete this. So the second part is the shortcut trick. You can use that. Thank you.